Good morning. Scanning electron microscope. The scanning electron microscope is used for observation of a specimen surface. When the specimen is irradiated with a fine electron beam called electron probe, secondary electrons are emitted from the specimen surface. Topography of surface can be observed by two-dimensional scanning of the electron probe over the surface and acquisition of an image from the detected secondary electrons. Characteristics information of sample using SEM topography, the surface feature of the object or how it looks, its texture, direct relation between these features and materials properties, morphology, the shape and size of particles making up the object, direct relation between these structures and material properties. The topography, how it looks, texture, direct relation between these features and materials, morphology, shape and size of particles making up, object, direct relation between this structure and material properties. Composition, the elements and compounds that the object is composed of and the relative amount of them. Direct relationship between composition and materials properties. Crystallography information, how the atoms are arranged in the object. Direct relation between these arrangements and materials properties. Principle. The basic principle is that a beam of electrons is generated by a suitable source, typically a tungsten filament or field emission gun. The electron beam is accelerated through a high voltage, example 20 kilovolt, and pass through the system of apertures and electromagnetic lanes to produce a thin beams of electrons. Then beam scans the surface of the specimen. The electrons are emitted from the specimen by the action of scanning beam and collected by the suitably positioned detector. How SEM works? SEM uses the electrons instead of light to form image. A beam of electrons is produced at the top of the microscope by hitting a metallic filament. The electron beam flows a vertical path to the microscope. It makes a way through electromagnetic lens which focus and direct the beam toward the sample. Once it hits sample, or electrons that is backscattered or secondary electrons are ejected from the sample. The detectors collected secondary electrons or backscattered electrons and convert them into signal that is sent to viewing the screen producing image. Instrumentation of SEM. The SEM is an instrument that produces a largely magnified image by using electrons instead of light to form an image. A beam of electrons is produced at the top of the microscope by electron gun. The electron beam flows a vertical path through the microscope which is held within the vacuum. This is the diagram of SEM. Electron source, anode, condenser lens, scan coils, objective lens, sample, secondary detector electrons. Parts of scanning electron microscope. SEM. The major components of scanning electron microscope include electron source. This is where electrons are produced under thermal heat at voltage of 1 to 40 kilovolt. The electrons condense into a beam that is used for the condition of an image and analysis. There are three types of electron sources that can be used, that is tungsten filament, lanthanum, hexaboride, and field emission gun. Lens. It has several condenser lenses that focus the beam of electrons from the source through the column, forming a narrow beam of electrons that form a spot called spot size. Scanning coil, they are used to deflect the beam over the specimen surface. Detector, it is made of several detectors that are able to differentiate the secondary electrons and backscattered electrons and the diffracted backscattered electrons. The functioning of the detectors highly depends on the voltage, speed, the density of the specimen. Difference between SEM and TEM. SEM, it is based on scattered electron capture, but TEM, it is based on the electron transmission technique. It is used in the study of sample surface and morphology. TEM is used to study the detailed internal composition, morphology, magnetic domain. Sample size is thick, sample size is thin is used in case of TEM. It is low resolution in case of SEM, but in case of TEM, it is high resolution. Large amount in multi-phase sample analysis is possible. Small amount of sample is analyzed. Image is shown in monitor or picture tube. Images are shown in fluorescent screen. 3D image can be observed in case of SEM. 2D image can be observed in case of TEM. It is used surface, powders, polish, imaging, dislocation, grain, and boundaries. Advantage of SEM. Advantage of SEM includes a wide area of application that detail 3D and topographical imaging and versatile garnered from different detectors. SEM are also easy to operate with proper training and advance in the computer technology and associated software make operation user-friendly. Although all samples must be prepared before placing vacuum chamber, most SEM samples requires minimal preparation action. Disadvantage. One disadvantage of SEM is size and cost. SEM are expensive, large, must be housed in area free of any possible electric, magnetic, and vibration interference. Maintenance involves keeping a steady voltage, current to electromagnetic coils, and circulation of cool water. SEMs are limited to solid inorganic samples, small enough to fit inside the vacuum chamber that can handle moderate vacuum pressure. Thanks for watching. Thank you for your patience. That is now. Bye bye. See you again.